We repair power supplies. No. 1-800-487-353 or 1-800-IT'S. Call now, operators are standing by. F it. Greetings, the Astro 30 here, and I'm back on this Chinese OCL amplifier kit, output capacitorless. Now, this channel works fine. This channel is outputting a negative DC voltage, or the negative rail, which is, in the case of how I had it set up, about 19 volt negative. Now, I don't want to spend too much time on this, because quite frankly I've got better things to do, but I am going to go through the process of fault finding and attempting to repair this amplifier. Now, I have a fair idea what may actually be the problem, and it's going to be very simple, but I could be wrong. So first I'm going to go through and with you guys, I don't want to make this video too long, but with you guys, how I'm going to go about fault finding the problem. Right, so this is a schematic again, and this is the actually the what are we doing? Left channel. This is supposed to be the left channel, but it's marked on schematic as the right hand channel, but whatever. Thing is, we know that we've got a negative DC voltage, which the negative DC rail is this line right at the bottom here. So that's going through this transistor Q14 here, and so because it's negative, I know it's going, this transistor here is being allowed to conduct and send the negative 19 volt up to the output. Now that could be for one of two reasons. Either this device is shorted, either between the collector and the emitter, or collector and base, and it's being allowed to conduct, which I know is not the case. That transistor checks out fine. Or it's being biased hard on, which is the only other reason why it would be in conduction. So working from the output stage back, we know that this transistor tests okay, because I've already done that. In fact, all the transistors test okay. So we need to now look at what the base of this is connected to, which is the collector of Q12 here, which is the driver, which is the other half of the C-clay pair, and of course what it's being biased by on the base, which is this diode, this resistor, and just up here, almost out of screen, is the voltage amplifier stage, the VAS, which is a PNP transistor connected to the positive rail via the emitter. So then it will come through the collector, which biases this transistor Q11, which is the positive half of the cycle going transistor, biasing that, and then it goes through this bias network down to this transistor to bias that on, and then bias the output stage accordingly. And this should all be operating at what is known as quiescent current, or where these output devices are almost near the point of cutoff. They're only just conducting and having very little current flow through the output. Now, because one of them's in hard conduction, it's either a biasing issue or one of these transistors is just not working. Even though it's testing okay in circuit, it's just refusing to work and behave itself accordingly. So now, knowing where I've got to start from, which is the output stage back, and I know it's this transistor over here is the issue, because that one is connected directly to the negative rail on its emitter. Knowing that all the components in the biasing network, I haven't checked R18 up to the collector of the VAS yet, but I'll do that in a sec. But at least all these components here, VD2, R19, Q12 and Q14, are all connected correctly. There's no reason why this should be outputting a negative 19 volt. So what I have to do, with not having to spend all day on this thing, is really hook up a power supply and take some voltage measurements. As I said, I have already checked the transistors. They appear to all be conducting, none are shorted. Just because they're conducting in normal diode test, even in circuit, doesn't mean to say they're working. I could still have to end up replacing transistors. I also went ahead off camera in the first video and checked all the resistors along here to make sure that none of them were open. Because from personal experience, if any of you have been following my channel, you may remember that particular amplifier had a problem on its output stage of the center channel, where it was sending a negative 51 volt DC through to the speakers. Of course, putting the amplifier into protection mode. Now, the actual fault turned out to be something really silly and had nothing to do with the output transistors being shorted, nothing to do with the driver or voltage driver IC being bad, which I also replaced. It turned out to be an open resistor on the base of the negative side. And because it wasn't receiving a base bias voltage, it somehow managed to put the whole output stage into full conduction on the negative. So that just goes to prove, don't rule out passive components as well as semiconductors. So always keep in mind that even an open resistor can cause weird and wonderful problems. So what I have to do is I have to hook up a power supply, as I said, go through and compare voltages on the working channel to the bad channel, starting from the output stage back along the line till I get to the VAS. So all the voltages on that side of the output stage up to the VAS, which is Q10 here, or BT10 as it's marked, and just make sure that comparing this VAS to its working channel next to it, that the voltage at the collector and the base is the same as it is here, because don't forget it's connected to the same positive rail. So there shouldn't be any variance. The only thing that could be a problem is this biasing resistor may be open. We could have a problem with the first transistor and the differential pair here. That may be causing this to go biasing the VAS hard on, which is then in turn biasing this driver transistor hard on, which in turn is biasing the output transistor hard on. So what we have to do is, as I say, start from the back, the output stage, and work backwards through the circuit. Okay, got everything set up here. Please note that I've set the power supply to plus minus 10 volt instead of the plus 21 minus 21 volt, because I just want to keep the voltages down a little on the circuit so I'm not over stressing a transistor or something unnecessarily. The thing will still work, and it just means that whatever voltages I measure over on the good channel, they have to be the same on this channel. So it doesn't really matter what the voltage is, it's just that when it's operating at its full voltage they're going to be higher. So first I'm going to set my multimeter to the 20 volt output, turn the load on, and just verify that we still have a DC offset on the output, and we do. We have negative 9.42 there. So that's pretty high. So first thing is first, I'm going to look at the base of VT14, which is the same as looking at the collector of VT12 or Q12. So that's with respect to negative. So negative is over here at this diode. In fact, I might make things easier and connect a fly lead. So I can connect that directly to the flux capacitor. No, so I can connect it directly to the negative lead, negative test lead, so I'm not having to sit there holding it. Now stand up, stay there. Alright, so Q12's collector is on the right, which is pin 3. And we have what looks like 70 millivolt maybe? Yeah, we've got 70 millivolt on the collector of Q12, which would be the collector of Q5 on the working channel. So double check that. Now there's the difference. We're at actually 6 millivolt there, and yet we've got 60 millivolt there. So there is our first clue. So now we look at the base of Q12, which is the center pin, with respect to negative. We apparently have about 5 millivolt there, and the same on Q5 is off the scale. Okay, so just increase that. We have full line voltage there, or positive 9 volt. So there's our second clue. So Q12's base is not being biased correctly. So that means I've got to now look at the anode of D2, which is going up towards the VAS now. We don't appear to have anything there, about 2 millivolts maybe. We should have, according to the working channel, 10 volt. So you can see where this is going. Then I have to look at what the voltage is across R18, which is next to it. We have nothing there, probably about 2 millivolt. And nothing there. So that side should be going to the collector of Q10, which is the VAS. So that's pin 3 of Q10. There is nothing coming out of that transistor. The VAS on the working channel is Q3, so the collector of Q3, off the scale, we have 10 volts there. So according to this, there should be 10 volts on the collector of Q10, but there isn't. So I'll let that run for a long run-on shot so you can see exactly where I was going. So I've actually measured all the way voltages up back to the collector of the VAS. Right, so the collector of the base of Q3, yeah, has 20 volts on it. The base of Q10 has 21 volts on it, so they're roughly the same. The collector of Q3 should have 10 volt on it, but the collector of Q10 has nothing on it. So even though this transistor Q10 is being biased on, it's not doing anything. So that could possibly mean that there is a problem with that transistor Q10, which is one of the 9012s, a PMP. So I'm just wondering, before I go any further, just doing a heat test on that, it doesn't appear to be getting hot. I'm just wondering what the voltage at Q8 is on the collector, which is nowhere to be seen. There it is. Collector, which is pin 3, is 21. That goes up to positive rail. Q9 should also be, well, that's at 10 volt now. So I'll look at Q2 collector. Right, there's another problem. The collector of Q2 should be at line voltage, but the collector of Q9 is only at 10 volt. Okay, and the collector of Q8 was full line voltage, so that would be the same as Q1, which its collector is at full line voltage. Okay, so there's a toss up now between Q8, Q9, sorry, and Q10. In case anyone's wondering what I'm doing, I'm just checking the solder joints around these transistors. I mean, they look alright, but they don't look much different to the working stage, but it's got a bit of the heat transfer compound all in between the joints here, but never rule out the obvious. I'm just checking to see that all the joints are actually soldered correctly first. I believe they are. So next step is to change Q8, I believe I said it was. No, not Q8, Q10, and go from there. Okay, I just checked and compared the 3096 with the 9012, and they're roughly comparable. They have the same base collector voltage of 40 volt DC anyway, but they don't give very many statistics on the 9012, like its voltage gain, HFE and all that sort of crap. However, I've removed Q10, the VAS, from the bad channel. Tested it out of circuit, but it still seems to be working fine. So now that that's out of circuit, I'm going to power it up, and we're going to see what happens now at the base of Q12, which is the end of the cathode of the diode there. So it shouldn't go bang, which it didn't. So if I go to the cathode of the diode, we have 0.1 volt there, and still 9 volt there. So we're still not getting any bias there now, because, well, the VAS is removed, so of course you're not going to get any bias. So what's the output of the amplifier on that channel doing now? So we still have 9.37 volts at the output, minus 9. So I now know that it wasn't the VAS that was the problem. It's actually further down the line now. So what I want to do is connect that back up to there. Now Q12's collector is giving me 70 millivolts, and the collector of Q5 conversely is giving me about 10 millivolts, so there's still a difference there. So this is leading me to believe that there's something wrong with the output stage, which there very well could be. So just for giggles, I'm going to look at the emitter of Q11, which is 600 millivolts, and that's also Q4 on the other channel. Is 10 volts. So yeah, we have an issue here. Well, this is interesting. I removed the output stage again, and I removed Q9, which is the second transistor of the differential amplifier. And when I removed the output stage, I still had like 10 volt positive this time on the output, but now I've got 70 millivolts. That was after removing Q9 and re-soldering it back in the board, funnily enough. So because I only have 60 millivolts on the output, which is almost the same as the other channel, that's with the output stage removed, mind you, I'm just wondering, because I did measure my suspect transistor with the weird voltage, which was Q9 at the collector. It was only half the voltage. Now we're at full line voltage on that collector, which is what it should be, which is compared with Q2 collector, which is that one there. They're both the same. 1 volt within each other anyway. So yeah, that's interesting. So what I'm interested to know now is, without the output stage connected, is this going to actually work as an amplifier? And the reason I say that is because, don't forget, these two driver transistors are actually in common emitter push-pull arrangements. So technically this is an output stage. However, it wouldn't deliver much wattage, probably in the order of a few milliwatts. But it's enough to connect an oscilloscope up to it and actually see by touching the input now if there's a blurt on the screen. So that's the next thing I'm going to try. Okay, so now I've got the DSO connected. I'm just going to turn the load back on. Nothing unusual on the output. Just going to measure the voltage at the output again. We've got 0 volt. So that's perfectly fine. There's now 0 volt on there. That's because I'm at 200 volts. So if I go back to 200 millivolt, yeah, we have about 6.9 millivolt on the left channel, which is perfectly fine. Now this is unloaded, it's not going into a dummy load. And would you look at that? We have a flicker on the DSO. I do believe we have a working amplifier stage now. Just to verify that, I'm going to increase the voltage on the power supply back up to 21 volt plus minus. I'll leave it at 16 for now. Still working as an amplifier. Now we're at 20 volt, which is roughly where it should be. Still working as an amplifier. Okay, well that's both perplexing and interesting at the same time, and all I did was remove one transistor and resolder it back in. Just goes to show that one small poor solder joint can spell the difference between a working thing and something that's not working. So yes, this video went on longer than I wanted it to, and I went through a lot of different testing procedures and voltage measurements and stuff to come to the final conclusion. My first thought on this was, okay, I've got one of the PMPs swapped or inversed with one of the NPNs. I've got a transistor in the wrong place, basically. That was the first thought. Then I verified that, and that ruled that out because they're all soldered in the correct way, where they should be. The second thing I thought of was, okay, we may have a poor solder joint, and that's exactly what it turned out to be. So I know that those output devices I've removed work, so what I'm going to do is I'm going to resolder them back in for the third time. I'm going to test it back again on 10 volts, see what's at the output, and then see what we've got on the DSO, and yeah, go from there. So I'm just going to do that now. Okay, the output stage is now soldered back in, I believe. I may have swapped the two around. I don't think I did because it looks like where it was, but I've noticed that the printing on the case of the transistor is starting to come off. Anyhow, got the power supply hooked back up, turn the load on, and measure the DC offset on the left channel. We have relatively nothing, probably about less than a millivolt, and it's the same on the right channel. So I know that the output seems to be okay, so I'll just hook the DSO back up to the output of the left channel. It's now working as an amplifier. So just to verify, I'm going to wind the voltage up to where it should be, which is 21. It's about there. Oh yeah, it's definitely working as an amplifier. That of course is unloaded, it's not going into a dummy load. So what I'll do is I'll hook up a dummy load. Okay, I've got the amplifier hooked up across an 8 ohm dummy load. Just untwist the DSO cables here. Right, so all going well, turn it on. Oh, I could hear a buzz, it was actually the dummy load buzzing. Drawing about an amp of current there. So, yep, that's working as an amplifier. So now to hook up a frequency generator to it and see if we get comparable results to the first one. It should be around about 8.5 watt. This is what electronics is all about, having shit everywhere. Now, I can see on the oscilloscope that we have got an output signal at, I believe it's 50 millivolt at 1 kilohertz. So if I change my voltage per division, yeah, it's noisy, but it's there. So I need to put this to its maximum, which is 300 millivolt. So we change that to 300 millivolt. Did that even change? It is now. That's clipping bad. We're drawing 2 amps of current. So let me change that to amp 0.3 volt. For some reason this is not going the same way as the last test. This is awfully strange. This is making me look like an idiot. 0.1. Jesus. Because that's, yeah, drawing way too much current. 0.05. 0.08. Man, this is embarrassing. I can't even work a DS. That's hot. I can't even work a DSO. Well, I was wondering what was going on here, and it turned out I connected the dummy load, the negative across the positive of the output. So I was actually essentially shorting the output stage out. And the heat sinks were getting red hot, and I couldn't figure out why can't I control the signal from the generator without sending it up to about 2 amps of current. Yeah, I had the output shorted, which is kind of a derp moment. So yeah, that was kind of idiotic, but I'm surprised that I didn't kill the output stage. But yeah, now we're down at 30 mA at about nothing. So if I put the amp back up to 150 millivolt, yeah, that's a bit better. We have a relatively good signal output. Now, I think I had this at 300 millivolt was the maximum before it peaked, clipped. So I'll put it at 300 millivolt. Yeah, it's clipping way too much there. So 275 millivolt. That's just bordering on clipping, and we're drawing around 500 mA. Output stage seems a lot happier now. So now I'll just swap outputs around back to the channel I was supposed to be testing to see if they are the same. So just swap those 2 cables around and swap the input, power it back up, and it's the same. So we have Vmax output of 17 volt there into an 8 ohm load, so we're still looking at 8.5 watt, which is all I wanted to actually test in the first place. So now that we know that the output stage is working, what I need to do is I need to adjust the gain of this amplifier, because 275 millivolt input is going to be too small, especially if you connect a preamp up to it or any other line device with no volume control in line with it. The gain's going to need to be changed to around about 23. So what I'm going to do, in the case of the left channel it's R16, which is there, I'm going to lift one end of the resistor, and I'm going to connect a variable resistor because I don't want this to go any lower than 240 ohm. I'm going to connect a variable resistor in series with it, and then put a potentiometer on it and adjust it until I get about an input sensitivity on the amplifier of about 1.5 volt peak to peak. And also, just for the sake of this thing here, I am really glad that having the output directly shorted like that, it didn't blow the thing up. It was heating up and drawing a lot of current, yes. Even if the output was shorted, the output stage would last a while, but these heat sinks are still red hot. So I've got to, let that cool down a bit, and then I'm going to, well, on the left channel anyway, I'm going to lift this resistor put a variable resistor in, about a 10k one, I got one somewhere, and adjust it until I get roughly the gain or the input sensitivity I want. I got a 10k variable resistor, 2 pins of the resistor from the center to one of the outer ones are actually bridged. That's going to the underside of the board where the resistor was removed. One end of the resistor is floating and the other end of the variable resistor is sitting at the end of that resistor. So that means now I can vary the amount of resistance on there. At the moment I should have 0 ohm on the variable resistor. Now I did say I didn't want to spend all day on this. I've spent about the last 2.5 hours on it. But yeah, you get that. Okay, so I should have 0 ohm on that variable resistor, which I do, and if I rotate it, it should increase, which it does. I'm now at 2.4. So I'm going to start at 0 ohm, which is the just like having the 240 ohm resistor in the circuit, and then I'm going to slowly increase it and watch the output on the DSO decrease, and then I'm going to slowly increase the output of the DDS until I get around about 1.5 volt peak to peak without clipping. So we'll just turn the load on again, and currently we're at full output, so I'll just increase. Oh, that was a sudden jump to almost a third of the output voltage. See how it's suddenly dropping, and I've only just rotated it about a quarter of a turn. So I know it's coming down. Go again for an amplitude of 1.2 volt. We're overdriving again. We're clipping. Reduce it down until the clipping goes away. So now we're at 1.2 volt and we've just got rid of clipping. We're at a nominal draw of about 600 mA, which is okay. So I'm going to say for 1.5 volt now, 1.5 volt, we're clipping, drop it down till the clipping goes away. There we go, we've got a nice clean signal now. So now at 1.5 volt input, that's no longer clipping, so now I need to know what the resistance value of that resistor is, so I can change the 240 ohm to that value. Keep in mind that I will have to add 240 to this reading when I pick the final resistor. So we're actually at 1.5k. I don't know how well you can see that, there's a cable in the way, but it says 1.5k. That would be plus 240 around about 1.8k. Now I could go 1.5k or I could go 1.8k. First I'm going to see if I've even got a 1.8k, which I don't have. I only have 1.5k's. The next one up from that was 2.2, so I'm going with 1.5. Now I'll turn the output back on and we're clipping slightly. So I'm going to change this now back to 1.3. That's almost clipping free, so I'll change that to 1.2, which is roughly where I wanted to be, and it's no longer clipping. We're outputting 17 volt peak to peak, thereabouts, and 500 mA. So I now know that we are working on an input sensitivity of 1.2 volt peak to peak before clipping, which is about roughly where it should be. So now I need to calculate what the gain is. Now, I've never tried doing this on camera before, but we need to know what the gain is. So it's R2 divided by R1, so I now need to know. I didn't change the 33k resistor, so it's 33 divided by 1.5, which equals 22 plus 1 equals a gain of 23, exactly where I wanted to be. So now that the gain's been adjusted on this, so a preamp will connect to it just fine. Both channels have been done now, so they're both running at a gain of 23. I guess the burning question is, how does it actually sound driving a speaker? Well, that's going to be my next thing. I'm going to set up those two little bookshelf speakers that I had before and pump in an audio source through these inputs, and yeah, we'll see how it actually outputs. Okay, I've got both speakers hooked up to the output, nothing to the input yet. What I'm going to do is power it up and just see if there's any strange noises coming out the speaker. No, just a thump. There's a bit of a buzz there. Bit of a buzz there. So it is working. There's a blurt there, so that's working. It's not too loud, so that's good. Now to hook it up to, I think I'll hook it up to my laptop, and we'll play some music through it. Okay, got it hooked up to the laptop. Let's play some music through it. I've got the volume right down. Just turn it up a bit. Okay, that sounds alright, so yeah. Yeah, right. This is all coming from the YouTube audio library. Okay. Okay, so that's enough of that. That is actually working properly. So I should probably run it for a while, but yeah, it seems to be working okay now. This left-hand channel, which is what they call it, it's actually the right, is now working perfectly, and all I did was remove Q9 and resolder it back in after testing it out of circuit, and it worked fine, only to find that the negative DC offset voltage at the output was gone. Okay, stranger things have happened. Covering the amplifier up for a few seconds just to show which resistors I've changed. R5, which is here, is a 240 ohm originally. I changed that to a 1.5, and I've also changed R16 also to a 1.5K. That's 1.5K, 1.5K, which gives us, in this feedback loop, an overall gain of 23. And it actually sounds pretty good, and it's not distorted. Anyway, I'm going to end this video here. It's gone on way longer than I wanted it to. But yeah, I can now finally put this amplifier to bed. I know it's working. I can now proceed to use it in what I was going to use it in. And just before I finish this video off, I've soldered in one of these 3-pin headers here, and of course the pad that lifted on the left hand side of that connector there was nothing to solder to anymore, so all I've done is just added a resistor cutoff lead there and soldered it to the capacitor next to it. That will work just fine. But these cheap Chinese boards, yeah, like that. They're cheap Bakelite boards with very thin copper on it, and I'm not sure what the measurement of the copper is, but pads and traces rip off very easily. Anyhow, that's completed, and I'm happy. Thanks for watching. I'm the Astro 30, and if you enjoyed this video, please remember to rate, comment and subscribe below, and you can always follow me on Facebook and Twitter. The links are in the description as usual. Also, you can support me on PayPal by donating as little or as much as you want, because your donation allows me to buy stuff to play around with on the channel. And speaking of channels, check out this guy, 12 Volt Vids. He has some great content to do with electronics on his channel. Anyway, this is the Astro 30 saying see ya, have a great day.